truth is in the data.
In the archives of forensic astronomy, some case files open not with a bang, but with a whisper of cold. Imagine a perfect photograph of a newborn universe, an image imprinted in microwave light. Just this is the cosmic microwave background, the CMB. It is the single most important primary source we have, a fossil echo that maps the minute temperature variations from which all structure, all galaxies, all of us, would eventually form. The standard model of cosmology predicts these variations, these hot and cold spots, to be random, a Gaussian For decades, our observations confirmed this elegant uniformity. The blueprint was flawless. Till we found the flaw. In 2004, data from the Wilkinson Microwave Anisotropy Probe, or WMAP. In the direction of the constellation Eridanus, there was a patch of sky spanning nearly 1 billion light-years that was anomalously, impossibly cold. It is colder than its surroundings by about 70 microkelvins, a deviation that may sound small, but on a cosmological scale, it represents a statistical improbability of staggering proportions. Initial analysis suggested a 1 in 2,000 chance of it being a random fluke. Later, more precise peer-reviewed data from the Planck satellite only deepened the mystery. This was not random noise. This was a coherent, structured anomaly. A single, colossal fingerprint on what should have been a clean slate. The existence of the CMB Cold Spot represents a fundamental challenge. The core principle of modern cosmology, that the universe is largely the same in all directions, is called into question by this single data point. It's a tear in our map of reality, a void that demands an explanation. Is it merely an extreme statistical outlier, the universe rolling loaded dice? Or is it evidence of something new, a structure or a physical phenomenon not accounted for in our theories? The implications are profound, forcing us to re-examine the very architecture of our cosmos. Now, let's open the classified case file and examine the evidence of this cosmic anomaly. The file is open. The primary source material consists of petabytes of telemetry from 2 of our most sensitive deep space observatories, the WMAP satellite and its successor, the European Space Agency's Planck Space Telescope. Think of these instruments not as cameras taking a picture, but as hypersensitive radio thermometers scanning the entire sky, measuring the temperature of creation's afterglow down to millionths of a degree. The resulting data set is a map, a celestial sphere rendered in pixels of temperature, where the history of the
Our first forensic task with any potential anomaly is to ensure the evidence is not corrupted.
An instrumental glitch, a processing error, a ghost in the machine, all must be ruled out. When the WMAP first flagged the anomaly, the scientific community treated it with professional skepticism. But this is why we build multiple independent instruments. The Planck satellite, launched years later, was a significant upgrade. It had higher resolution, greater sensitivity. Its mission was to create the definitive map of the CMB. When we processed the Planck data, we aimed its powerful analytical tools at the coordinates in Eridanus. The result was unequivocal. The cold spot was still there, sharper and more defined than before. This was not an artifact. This was a genuine feature of the sky, a confirmed piece of cosmological evidence. With its existence verified, we move to characterization. The forensic details are what elevate this from a curiosity to a profound enigma. On the sky, the anomaly subtends an angle of about 5 degrees. That is 10 times the width of the full moon. The scale is almost incomprehensible. At the distance of the CMB, it represents more telling than its size, however, is its morphology. Advanced analysis of the peer-reviewed data reveals a complex structure, not just a simple cold patch, but a deep, cold core surrounded by a slightly elevated, hotter ring. This specific profile is what physicists call non-Gaussian. In layman's terms, it is not random. The uniform, static-like hiss of the Big Bang is expected to have random peaks and valleys, but this feature looks structured. It has a shape, an anatomy that suggests a specific causal event rather than a simple accident of probability. This brings us to the core of the investigation, the statistical tension. We have run countless cosmological simulations, complex computer models based on the standard model that generate virtual universes. We let these simulated universes evolve, and then we look for features like the cold spot. The results are stark. A cold spot that is this large, this cold, and this structured is an extreme outlier. Answerless. The initial 1 in 2,000 odds have been debated and refined, but the conclusion remains the same. Within the to rely on chance here is akin to finding a perfectly circular crater a mile wide and insisting it was formed by random wind erosion. It is a possibility, but one so remote that forensic discipline demands we search for a better explanation. The final piece of our due diligence was to eliminate foreground contamination. Exhaustive, multi-frequency analysis has effectively ruled this out. The cold is real, it is ancient, and its signal is clean. The evidence is on the table. With the evidence confirmed and characterized, the investigation enters its most contentious phase, identifying the perpetrator. For the CMB Cold Spot, 2 primary suspects have emerged from the theoretical lineup. The other matches the evidence with uncanny precision, but requires a leap into the unknown. This is the central conflict of the case. Les Cerbre. Our first suspect is the most conventional, an immense cosmic void. The theory is known as it is a subtle consequence of general relativity and the accelerating expansion of our universe, driven by dark energy. This is a testable hypothesis. If a colossal void lies in the foreground between us and the cold spot, using deep sky galaxy surveys as our forensic tool, we mapped the 3-dimensional distribution of matter cataloged as the Eridanus Supervoid. It is a gargantuan underdensity of galaxies, over 1 billion light-years across. But when we ran the numbers, the theory began to unravel. The forensic models, which connect the size and emptiness of the void, the Eridanus Supervoid, as vast as it is simply not empty enough. It can only account for, at most. This insufficiency forces us to consider our second suspect, a far more exotic and controversial perpetrator. Bapsfield. This theory proposes that the cold spot is not a foreground effect at all, but a genuine, primordial feature imprinted. Proponents of this theory have simulated such a collision, and the predicted signature is striking, a large. We are left with a stark choice, an explanation we can prove exists but doesn't fit the facts. This is the conflict at the heart of this investigation, a standoff between an insufficient known and a perfectly tailored unknown.
So where does our forensic analysis leave us? We stand at an impasse, with 2 suspects, neither of which can be convicted.
The case against the Eridanus Supervoid is weakened by a quantitative evidence gap. Its effect is real, but demonstrably insufficient. The case for a multiverse collision is compelling in its descriptive power. It fits the profile of the anomaly perfectly. But it is built on a theoretical foundation, for which we have no other proof. It remains a ghost, an unsubstantiated but tantalizing possibility. This is the frustrating, yet honest, reality of working at the frontier. The data is unambiguous, but the interpretation is clouded. Therefore, the official status of this case file must remain open. We cannot, with forensic certainty, close the book on the CMB Cold Spot. What we have is not a failure, but a precisely defined boundary of our knowledge. The anomaly has provided a clear directive for future investigation. We must conduct more sensitive surveys of the Eridanus supervoid to refine our understanding of its structure and gravitational influence. We must also continue to scan the CMB for other similar anomalies, searching for patterns that might... And in the realm of theory, we must seek ways to make the multiverse hypothesis testable, to drag it from the realm of speculation into the domain of falsifiable science. This is where the trail goes cold, leaving us at the edge of the map with more questions than answers. The cold spot serves as a profound and humbling reminder that the cosmos is not obligated to conform to our expectations. It underscores the true nature of scientific inquiry, a patient, persistent process of questioning the void, knowing that its greatest secrets are reserved for those who have the discipline to keep searching the evidence for the truth, no matter where it leads.